Okay, I hear the recording in progress, so we'll share the screen. Essentially, we're just about done with the course. Okay, so for this upcoming test on Thursday, again, it's Thursday, not Friday, we're covering the parabola, the ellipse, the hyperbola, and parametric equations. So we're here. I'm marking this off, so we're just about done here. Okay, so I'll do some review questions today. I'll do some review questions tomorrow. Probably finish very early. Okay, so exam is Thursday. Usual requirements, you submit the homework, at least 70% of the homework. This is what you turn in, and then you prepare for the final exam. Okay, Friday will just be a glorified office hour. You can come or not. If you have any questions, show up. If you don't have any questions, don't show up. Final exam is Monday, 8:10 to 10:40. Use the same Zoom link. Okay, I'll set it up so that the Zoom link still works. And most likely scenario is 18 questions, 3 from each of the previous exams. 3 times 6 is 18. Okay, and I might throw in a couple more from somewhere else. You have 2.5 hours for the final exam. And my suggestion is review 2 tests a day, 2 on Friday, 2 on Saturday, 2 on Sunday. The videos are always the day after the tests. So to find the exam 1 video, look under Saturday 9/4. Exam 2 will be Saturday 9/18. Exam 3, Saturday 10/9, and so on. Okay, so you have them all except for exam 6. Obviously, we haven't had it yet. So I'll send this exam on Friday the 10th. Okay, again, you may not get back your individual test Friday. I'm hoping for the weekend, but even if I don't, you can still use the video to study for the final exam. I'll still get to your test and your final eventually. So you know that. And once again, I do have office hours during finals week. I say it because I'm supposed to, although I'm not guessing that too many of you will show up because it's already after the fact of the final exam. But if you need to catch me, let me know. It's a different Zoom session. So if you want to catch me, let me know. You can always email me if you wish. Okay.
May I ask a question about exam 6?
Mm-hmm.
So I noticed in studying yesterday that some questions from 6.2 and 6.3 were similar. You had to manipulate them into getting the equation you need to graph it. Are we going to be told whether it's going to be a parabola or an ellipse or any of the other ones? Or
Okay, so are you going to be told that it's a parabola, ellipse, or hyperbola? Not necessarily, although I could. So you should be able to recognize from the formulas that it is a parabola, ellipse, or hyperbola. Although I usually tend to give the questions in order. So the first problems are probably going to be parabolas, and then the next ones are going to be ellipses, and the next one is going to be hyperbolas. But but parabolas.
In 6.2 and 6.3, it started as there ones like 6x squared minus 4y squared minus 8x plus 16y or something, and you have to manipulate it. Are any of them going to be in that form and not tell us which one it is?
Are they going to have to be manipulated? For sure. And it's possible, it's fair game that I don't tell you what the shape is, although I could tell you. But for a parabola, you have one of the variables squared and the other isn't. So either you have x squared but not y, or y squared and not x.
That's a good point. Thank you. Yeah, I see. Yeah.
For ellipses and hyperbolas, you have x squared and y squared. The difference being for ellipses, they're pluses. Hyperbolas, there's a minus. So
that's perfect. Thank you.
That's how you tell right away. Yeah. Okay. All right. So again, for the final exam, study the previous exams over the weekend, and 3 questions from each test. They don't have to be the very same questions, maybe modifications, although they're allowed to be the same. And let's see, you don't have to submit any homework. You don't have to turn in any homework. And you can have 6 formula sheets. Just if you still have the formula sheets from the previous exams, just bring them in again. No need to reinvent the wheel. Just do the same ones. And if you want to add to them, you can. So 6 cheat sheets for the final exam. Okay. And then it's all over before you know it. What do we have? Less than a week in our course. And then sometime during next week, I'll email you your final exam score and final grade, and then we're done. Okay. All right. So I think that's as much as I want to say. Yeah, that some of you saying, yeah, you say this every day. Yeah, it's intentional. The repetition is important to make sure I catch everybody. Some people don't catch it all, or you miss it the first time. But it's basically to give students no excuse. So, oh, I didn't know when was the test. I didn't know when was the final, because I've been saying it every day, pretty much, or almost every day. So it's not just one time. Theoretically, if you say it one time, that should be enough. But if you say it, multiple times, that really leaves no excuse. Oh, I didn't know the test was Thursday. I didn't know the final was Monday. Or, I didn't know we could have 6 cheat sheets or whatever, right? So that's why the repetition. Okay. All right. So on to my version of review. Okay, so back in 6.2, number 11, and this kind of goes along with the question of manipulating x squared minus 4x minus 2y, sorry, that's a minus plus 2 equals 0. And yes, right away, you say, how do you know what's the shape? Of course, we're kind of cheating. We know it's 6.2, and we already knew 6.2 was parabolas. But yeah, most of the questions are going to be in order. So yes, we did say parabola, ellipse, hyperbola, parametric equations. Parabola, ellipse, hyperbola, parametric equations. But if you're not told that, what tells me right away for this one is I see an x squared, no y squared. That's automatically a parabola. Or y is squared, but no x squared. Okay, so move these two guys over, 2y minus 2. Complete the square. Remember, completing the square, take half the coefficient of x and square it. So half of negative 4 is negative 2. Square it plus 4. So plus 4 on both sides. And in some more difficult circumstances, remember, there might be some coefficient in front where you'd have to multiply that out. So let's pretend there was a 3 in front, right? 3 parentheses. Then it would actually be 3 times 4 is 12. So you'd have to add 12 to both sides. Okay, so this factors in x minus 2 squared. This is 2y plus 2, or 2 parentheses y plus 1. So this tells me squared in x, not in y, positive. So it opens up. Furthermore, this thing, the 2 is 4p. 4p is 2, so p is a half. X minus 2 squared is 4p y plus 1. So the vertex is at 2, negative 1, the translated parabola, right? 2, negative 1, p is a half. So I go to 2, negative 1, opening up, p is a half. So I'll go half a unit up, because the focus is always on the inside of the curve, half a unit down. So focus is 2 comma negative a half. Directrix is y equals negative 1.5, or y equals negative 3 over 2. Okay. And had a question about 6.3, number 5. 16x squared plus 25y squared equals 400. Okay, see something in the chat. Okay, I have a request for a problem. I'll get to it later, maybe. Okay, so I'll check back later. So divide by 400. So for the ellipse, you always want this to be 1. And how do I know it's an ellipse? Both x and y are squared, and I only see a plus. For hyperbola, there's an x and a y squared, but there's a minus somewhere. Okay, divide by 400. X squared over 25 plus y squared over 16 equals 1. Center of the origin. If it's not center of the origin, you'd have to have x minus something, or y plus something, or something like that. Okay, square root of these guys. A is 5, B is 4. Convention is that A goes with a larger number for ellipses. So A is 5, B is 4. A squared equals B squared plus C squared for the ellipse. You can put it on your cheat sheet, although I made my last class memorize it. Memory trick was E stands for ellipse. That's a vowel. So the vowel A stands alone. A squared equals B squared plus C squared. Hyperbola starts with an H, which is a consonant. So it's A squared plus B squared equals C squared. C stands alone, the consonant. Anyway. So C is 3. This is the 3, 4, 5 case. Put a 5 here, that's 25. Put a 4 here, that's 16. 25 minus 16 is 9, which is c squared, c is 3. Okay, so bulging horizontally, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So my vertices are negative 5, 0, and 5, 0. Up and down is 4. So 0, 4, 0, negative 4, the endpoints of the minor axis. Foci, one focus, two foci, always along the major axis. C is 3. So 1, 2, 3, 1, 2, 3. Focus 1 is negative 3, 0. Focus 2 is 3, 0. Okay, back to 6.23. 9y equals negative 16x squared. Okay, first I divide by negative 16. I got to make it look at my standard form. X squared equals negative 9/16 y. Okay, so vertex is at the origin. There's no parentheses stuff. And let's see, square root in x, not in y, and a negative. So that tells me it's opening down. And this is negative 4py. So I have to solve the awkward equation. Negative 9/16 is equal to negative 4p. So 4p is 9/16. Multiply both sides by 1/4. And I get p is equal to 9/64. So in other words, x squared equals negative 4, 9/64 y. So vertex is at the origin. I already know it opens down. So go 9/64 down. Focus is 0, negative 9/64. And my directrix is y equals 9/64. And there we go. Okay, 6.217 was asked for. Okay, you have all this stuff here, right? So how do I do with all this stuff? So move the y and the 8 over. Factor out the 3. So if I factor out the 3, I have x squared minus 4x. This becomes negative 4y minus 8. Complete the square, half and square. Half of negative 4 is negative 2. Negative 2 squared is 4. So I'll put plus 4, but that plus 4 is really plus 12. That's that distributive law I was talking about, right? It's really adding 12. So this factors into 3 times x minus 2 squared. This is negative 4y plus 4. Factor into negative 4 parentheses y minus 1. Divide both sides by 3. So x minus 2 squared equals negative 4/3, which I can write as negative 4 times 1/3 times y minus 1. Okay, so square root in x, not in y, negative, so it opens down. Okay, so vertex is at 2, 1, 2, 1, opens down. So I go down 1/3 of a unit for the focus. So 1 minus 1/3 is 2/3. So focus is 2, 2/3. For the directrix, I go 1/3 of a unit up, which is 1 and 1/3, or 4/3. So directrix is y equals 4/3. Okay. And let me check the chat. Okay, I have 2 requests for 6.219. Okay, I'll make a note of that. I'm not sure I'll get to it, or I may have it on my schedule for tomorrow. 6.2, number 19. Okay, so I'll mark it in case I forget. Okay. So let's see, I think that's that. And 6.3. Number 5. Oh, I already did that one. So jump ahead. 6.325. 6.3 now. Show you where I am in the book. Where am I? $6.325. Vertices -4, -2, -4, 8, and a focus at -4, 0. Okay, so if they ever give you two vertices or two foci, the midpoint will be the center. Okay, so the center is -4, 3. That's halfway between these 2 points. Okay, how do you find that? Well, the -4 is the same. And then you can take the average of these two coordinates, add them up and divide by 2. 8 plus a -2 is 6. 6 divided by 2 is 3. So the center is -4, 3. So automatically it's x plus 4 squared over something plus y minus 3 squared over something equals 1. Okay, so the distance from here to either vertex is 5. So that tells me 25 goes here. And then C is 3 because they give me a focus at -4, 0. So the distance from the center to a focus is 3. So C is 3. That is going to be my 3, 4, 5. Okay, since A squared equals B squared plus C squared. Okay, so 5 goes here, that gives me 25. 3 goes here, that gives me 9. Right? 25 equals B squared plus 9. So B squared is 16. So B is 4. That makes this 16. So x plus 4 squared over 16 plus y minus 3 squared over 25 equals 1. Okay. So there we go. Okay, I had a question about 6.4, number 9. 3x squared minus y squared equals 6x. Okay, let me move this 6x over. 3x squared minus 6x minus y squared equals 0. And by the way, this also tells me, not because it's section 6.4, but I have a hyperbola because I have x squared and y squared both, except this one's a negative and a positive. So that tells me it's a hyperbola. Okay, factor out the 3. So if I factor out the 3, I have 3 times x squared minus 2x minus y squared equals 0. Okay, complete the square. Half of -2, half the coefficient of x. Half of -2 is -1. -1 squared is 1. So plus 1 here, but that's really plus 3. 3 over here. 3 times factoring x minus 1 squared minus y squared equals 3. Divide both sides by 3. X minus 1 squared over 1 minus y squared over 3 equals 1. Okay, so there's my hyperbola. Square root in x, square root in y. This one's a negative, so I know it's going to open horizontally. My center is 1, 0. So A is 1, B is radical 3. So for the hyperbola, remember for the hyperbola, the designation for A and B isn't which is the larger number. It's the positive one goes with A, the negative goes with B. And maybe you can play the game of, well, every positive number is bigger than every negative number, so it doesn't matter in size which is the larger, right? 1 is still bigger than -3, I guess, if you want to think of it that way. And that's about 1.7. That just helps me with the graph. For the hyperbola, A squared plus B squared equals C squared. So 1 squared, radical 3 squared, C squared is 4, so C is 2. All right, center, 1, 0. Left and right, 1. Up and down, radical 3, 1.7. Focus, focal length is 2, focus is 2. So 1, 2, 1, 2. So -1, 0 is one focus, And the other focus is 3, 0. That should be a 3 there. Sorry. 3, 0. Draw my box, connect the diagonals. Slope is over 1 and up radical 3. So y minus y1 equals m times x minus x1. Y minus 0 equals radical 3, x minus 1. Y minus 0 equals negative radical 3, x minus 1. Okay. Okay, I'm about to do 21, but I was just noticing something about that parabola pop a couple of people asked about. I think at this stage, I'm going to throw it out. If you did it, great. Sorry to make you go through it, but I don't think it's worth discussing at this stage of the game. So let's go ahead and skip 6.219. Sorry about that if you tried it. If I actually have time tomorrow, I'll go over it. But now that I've said I'm not going to do it because it's very different than any other problems we've had. Okay, so let's skip 19. So 6.2, skip 19. It's interesting, but I haven't talked about anything like that. So let's skip that one. Add that to the skip list. Skip 19. Okay, and let's see, 21. Six 6.421. Foci negative 1454, vertex at 0, 4. Okay, go halfway between these two to get the center. Both of these y coordinates are 4, so you know the y value is 4. What's halfway between negative 1 and 5? 2. You can reason it out or graph it, or just use the formula, add them up and divide by 2. 5 plus a negative 1 is 4, divided by 2 is 2. So my center is 2, 4. And it is true that if I go this way, that's 3 units, and if I go this way, it's also 3 units. So it is right in the middle. These are the two foci, so C is 3. A is 2 because they give me a vertex at 0, 4. From 2, 4 to 0, 4, that's 2 units. Okay, and furthermore, I again know that it's opening left and right. So its center is 2, 4. So automatically it's x minus 2 squared over something minus y minus 4 squared over something equals 1. So I just need the somethings. I already have the a, so a squared is 4. So 4 goes here. How about here? A squared plus b squared equals c squared. A squared is 4. C squared is 9. Subtract, b squared is 5. B is radical 5. So b squared, or 5, goes over here. So here's my answer. X minus 2 squared over 4 minus y minus 4 squared over 5 equals 1. Okay. Okay, a couple of little reminders about ellipses and hyperbolas that I made up here. So 2 different types of ellipses. These aren't in the text. I'm just making it up. So for ellipse, you have x and y squared, both positive. Hyperbola, you have x and y squared, but one's positive and one's negative. For the parabola, x is squared and y isn't, or vice versa. Y is squared and x isn't. For the ellipse, it's either going to be bulging horizontally or vertically. That depends on which is the larger number. If the number underneath the x is larger, it's bulging horizontally. If I switch it, then it's bulging vertically. The larger number is underneath the y. Because this tells me I'm going 6 units left and right, and I'm only going 3 units up and down. Here, I'm only going 3 units left and right. I'm going 6 units up and down, so it's going to be bulging this way. For the hyperbola, we said it doesn't matter whether this number is bigger than this, or this number is bigger than this, or they could even be equal. It's still a hyperbola. If x gets the positive and y the negative, it goes this way, left and right. If they give it to me with y positive and x negative, with a negative sign here, okay, then it's going to go up and down. Okay, that will not change the designation of A or B, right? So A might be bigger, A might be smaller, or they can even be equal. It's still the same thing. Okay. Okay, folks. That was just about all I was going to cover. Maybe I'll just rehash one thing back in 6.7. Somebody asked for 6.77. And after this, I'm finished, folks. So if anybody wants to ask a question, you may. Otherwise, I'm done for the day. And tomorrow I'll be sort of the same. I'll do a few problems you can ask, but that's about it. 6.7, number 7. How do you eliminate the parameter, right? (6.77) x equals secant t, y equals tan t. So once I see this, I'll use the identity 1 plus tangent squared x equals secant squared x. Well, since I set y to be tangent t, 1 plus y squared. And secant squared t is now x squared. So I have 1 plus y squared equals x squared. Move the y squared over. 1 equals x squared minus y squared, which is the same thing as x squared minus y squared equals 1. So that's a hyperbola. I can pretend there's an over 1 here. Opens left and right. So 1 to the left, 1 to the right, 1 up, 1 down. Draw my box. This is y equals x. This is y equals negative x. And goes like so. And yeah, the c is going to be radical 2. I'll go ahead and do that. A squared plus b squared equals c squared. So 1 plus 1 is c squared. C squared equals 2. So c is radical 2, which is about 1.4. Okay, so the foci go 1.4 this way, 1.4 this way. So focus 1, focus 2. Negative radical 2, comma 0, and radical 2, comma 0. So that's that one. Okay, and that was about it, folks. So tomorrow I might do a couple more problems, but otherwise I'll let you ask questions the rest of the time. And that's true for today too. Okay, so let me stop the share and see if anybody else has a question. Otherwise we're finished, folks. So tomorrow's our last day of regular instruction, and then the test is Thursday. Okay, let me check the chat. I just had 6.219 questions. So you had 6.219 are thrown out. I showed that to you. Okay, any other questions, please? Otherwise, we're done for the day. All right, so have a good day, and we'll see everybody next time. Okay. All right, bye, everybody.
Thank
Thank
you.
you.
Thank you.